Hello, everybody. So I will be going over every problem on your practice test number 1 for Calculus 1. I will probably do like 4 exercises each time. And so you will end up with a series of videos so that you'll not have like one big, long video, but you'll have a series of a few small, short clips. Let's get started. All right, so just to make sure we all understand what's happening, practice test number 1 is for your test number 1. That's on chapters 1 and 2 of the OpenStax Calculus Volume 1 textbook. The details of practice or the details of the real test number 1 can be seen here in these 3 bullet points. All right, I will be starting with number 1 and probably will do about 4 problems each. All right, so let's get started now. All right, so question number 1, trying to find the domain of this function. Now, this is a rational function. You have a fraction, right, where the denominator is a polynomial. And the only thing, and by the way, the domain is supposed to be like every real number or the set of all real numbers, unless you need to exclude some real numbers because those would not make sense. Okay, for instance, here, a fraction is defined pretty much for any top and bottom except when the bottom is 0. Okay, so the only situation you have to avoid here is the 0 denominator, right? So you set the denominator equal to 0, and of course you just get 2 values for that, right? X cannot be 2 or -2. In this case, -2 is no good, 2 is no good. And these are the only 2 that you need to exclude. Everybody else is welcome, okay? All are welcome except for these 2. And so you can write this in a couple of different ways. And I will accept any of these. You could say all reals or all real numbers except 2 and -2. So that would be an acceptable way of saying this. You could also say, using set builder notation, it's a set of all x such that x is not plus or minus 2. That's certainly acceptable. You can also use what is called the interval notation. From -infinity to -2 is fine. Union -2 to 2. Union 2 to infinity. This is a very nice way of saying all of these are welcome except for -2 and 2. You see, because we use open intervals, we carefully exclude only those 2 points, 2 real numbers. Everybody else is okay. All right, let's go to number 2. All right, so we are to find the domain and the range of this function. When you have a radical function, the square root function, the only thing you have to be careful about is that inside the radical, you have to have a non-negative number. 0 is okay. So what we need is this to be greater than or equal to 0. Now you can just add x to both sides and you just get that, right? So this is just saying that x has to be less than or equal to 5. Now you can again use the set builder notation, saying the domain is the set of all x so that x is less than or equal to 5. That's certainly fine. You could also say from -infinity to 5, and this time you make sure you use this square bracket to include the endpoint 5 because square root of 0 is acceptable. Right. You could also say in English, all reals less than or equal to, I would not encourage you to do this because it's so wordy. Less than or equal to 5. That's certainly acceptable, even though I would prefer this or this mathematical notation. All right, now the range is a little more challenging, okay? And I will not be asking you to provide the range on the exam, so I don't think you have to spend too much time on this, but I will tell you what the range, how to find the range, okay? It is a little tricky, so be careful. First of all, we know that this expression, whenever you use the square root of something, unless you have this negative sign here, what we mean by this radical sign is that it's always positive or zero, okay? We are looking for what we call the principal square root. So this is always going to be at least zero. It cannot be negative. And now the question is, can y be any non-negative number? Okay, so let y be, and here's the situation. Let y be greater than or equal to zero. The thought process is, if somebody gives you just an arbitrary y value which is not negative, let's say 3 or 3,000 or pi or 2,475,000, can you come up with x such that f of x is that y value? All right, that's the question. And if you can do that, then the range has to be all of these numbers. Okay, so let y be the square root of negative x plus 5. If you square both sides, you get that. All right, so this tells me exactly how you find your x, right? X is equal to negative y squared plus 5. Now, what is this telling us? Well, basically, it's telling us how you can find any, for any y value somebody challenges you with, which as long as y is not a negative number, okay, you can find x so that f of x is equal to that desired y value. All right, so you actually got what you wanted to get. Y is going to be any number that is greater than or equal to 0. So the range of this function is, again, you can write in set builder notation like this, or you can say this is from 0 to infinity, 0 included, infinity, of course, not included. You could also, if you can figure out the graph of this function, the graph is looking like this. And so from the graph, you can see, well, maybe you can't, but from the graph, theoretically, you can see this is a square root function. So this goes on forever for any y value. Okay, I mean, this is going to grow slowly, but if you keep going to the left, eventually it's going to go beyond any real number. So the range is from 0 to infinity. Okay, and so that's how and 0 is included because there is this point here. Okay, so that's number 2. Let's go to number 3. All right, the domain. Is there any x value you need to exclude? Well, x squared is defined for any real number, and e to a number is defined for any real number. So there's really nothing to exclude, right? So the domain is the entire set of real numbers, which you can denote with this script R or boldface R. You can also write this as the entire interval from negative infinity to positive infinity. That's also acceptable. Basically, the domain is the set of all reals. Okay, so that's not too hard. Again, don't spend too much time on this range because I will most likely not be asking you a hard question like the range of a particular function. But for this one, right now, it may be helpful to know what e to the x looks like. E to the x looks like this, right? It grows faster and faster. And we will study this very carefully from the standpoint of calculus. But for e to the x, this is called an exponential function, and literally it grows exponentially. And so here is 0, 1, and it goes on like this. Now, we are talking about e to something, right? Now, the point is x squared is never going to be negative, okay? X squared can be 0, but e to the x squared, where this number cannot be negative, could be as small as 0, is going to be taking a y value that is only corresponding to this part of the graph. You see that? Because e to the x squared, where x squared cannot be negative, will not be on the left-hand side. So this graph tells you that the range is going to be from 1 to infinity, right? It's all these y values, okay? Because you have this x squared, which cannot be negative, this function cannot take on a y value that's going to be less than 1, right? So that's the way to think about this. Now, if somebody gives you an arbitrary number, which is 1 or bigger than 1, Okay, so this is what you are trying to do, right? And so you can take the log of both sides. Log of 1 is a, if y is 1 or bigger, this is going to be a non-negative number. And so this will be x squared. You can take the square root of both sides, plus or minus. And in fact, I will be able to find two numbers. Well, okay, if y is greater than 1, I will be able to find two different x values so that f of x is going to be exactly that y. Okay, if somebody says, hey, look, I want my y to be 3,000. What I can do is to take the natural log of 3,000, take the square root of it, which will be, positive. And then I can put plus or minus that square root of natural log of 3,000. If I plug that number in here for x, I will have f of x to be 3,000. So the range is going to be basically any number that's greater than or equal to 1. All right, so that's number 3. Let's go to number 4. All right, so the answer key states this too, but odd means that, so to check if a function is odd or even or neither, what you have to do is to replace x with negative x and see what happens, right? And if nothing changes, if f of negative x is still f of x, then that means you have a graph that's symmetric with respect to the y-axis, and that's going to make the function even. If you get the opposite of f of x, then when x becomes negative, y also becomes negative, which gives you symmetry with respect to the origin, 180-degree rotational symmetry. If neither of those things happens, then we say it's neither. All right, so really the only process that you have to take here is to replace x with negative x and see what happens to the value of the function. So when you do this, by the way, you can almost tell, I think we can tell that the first one is neither. What's going to happen is for the square function, negative x squared, quantity square is the same as x squared, so nothing changes, right? But for the second one, just x becomes negative x, that's the difference. It changes, and then the positive 1 doesn't change. So you have a mixture of positive and negative. This is not f of negative, f of negative x is not f of x, clearly. And it's not negative f of x. Once again, the first and the last remain the same, but the middle one changes its sign. So this is neither. Neither odd, nor even. For this one, g of negative x is negative x to the 4th plus negative x squared, which is of course x to the 4th plus x squared, because both of these are even functions themselves. And so, oops, that's not, this is minus, right? And so nothing changes. This is exactly where you started with. It's g of x, and therefore it's even. Okay, so that means it's symmetric with respect to the y-axis. Q of negative x is negative x to the 3rd power minus sine of negative x. Okay, now it turns out, as you know, x to the 3rd power itself is an odd function, and so is sine of x. So then what you get is negative x cubed minus negative sine, which is positive sine of x. Okay, and if you look really carefully, this is exactly the opposite of that. So this is negative q of x, and that gives you the fact that it is an odd function. You can see that an odd function plus an odd function will also give you an odd function. All right, so what's this one here? P of negative x is negative x to the 3rd power, quantity to the 3rd power minus 1. Notice here, when you have a constant, of course, nothing changes because it's a constant. So then you have negative x cubed minus 1, which looks sort of like the negative of px, but it's not, right? Negative of px will be negative x cubed plus 1. And so this is not negative p of x or p of x, and therefore it's neither. Okay, so far you have neither, even, odd and neither. Let's go to the last one, R of X. Notice here, this is the X to the 6th is an even function. So when you replace X with negative X, you have negative X to the 6th power minus 1. That's X to the 6th minus 1. So this time, this one remained the same, and the constant will still remain the same because it's a constant. And notice here, this is exactly what you started with. Okay, so the tricky thing is, when you have a constant that follows a even function, the whole thing is going to be even. But that doesn't happen with a odd function. When you have an odd function followed by or where the constant is added or subtracted, then it ceases to be an odd function. All right, so here the last one, it is the same as R of X, and therefore it is even. Okay, so that's the answer. Those are the answers to the first 4 questions.